Do you want to move from topic to topic? You're editing the doc, you seemed.
Sorry?
So do you want to move us from topic to topic?
Sure.
Like you had an order.
Hi everyone. So moving first to the PI issues, we first have a compile regression cannot infer appropriate lifetime for lifetime parameters. The issue is 70917. And ADB, perhaps you would like to discuss this one. Or Nico, you also left a comment I saw just a minute ago.
Yeah, either way. I mean, what's happening here is when we reference the capture lifetime function, there's a unique type associated with it. And for some reason, correct me if I'm wrong, Eddie, it seems like so you can sort of think of this type as almost as though, yeah, as basically like a kind of struct where it says, capture lifetime TK with the type parameters from the function. And then this call requires that that be static, and that doesn't work because TK is not static. And if this were a struct, we would definitely give an error in this situation. We don't, it seems like we didn't report an error before. I think I didn't 100% dig into this, but from what I can tell, I think that was basically just an oversight. So I think this is probably a bug fix. At least that's my current opinion. In terms of what we can do about it, I don't know.
So
I guess we can see what
the
impact is.
Sorry, can you repeat that?
I said getting some idea how big the impact is would be one thing. Looks like we have two notes up there. We could certainly special case this and continue forward behavior. I don't think, either for a time or indefinitely. I don't think I don't actually think, can I say this? I don't think it's unsound to have the old behavior necessarily, but I'm not 100% sure. But there's the primary, this kind of intersects like some rules that we adopted in RFC 1214, which basically say if you have a struct, let's say, or just any type, if you have a type, like foo of x, and it has to outlive some region tick y, then x has to outlive tick y for all components x, right? And there are reasons for this, but it's actually kind of simpler than you might need. And I don't like the behavior in some cases, and I've actually been wondering if we can change it, though it would be interesting. The most obvious example would be something like this. Basically, the question is, does the outlive needs to, at minimum, guarantee that whatever data is in there lives longer than tick y. It also has another rule, which is what RFC 1214 talks about, that has to do with associated types, where you can kind of write impls like that kind of capture this tick A and are able to use it. And you can go read the RFC, but I think we have a big agenda, or I can talk about it in more detail later. But suffice to say, if we didn't, it may be that even if there is no data that references that X, you could still get unsoundnesses as long as you can sort of capture it through an impl like this. However, you can't do that with these types because they're anonymous. So you can't write like an impl tick A some trait for capture lifetime of tick A, at least not today. Now, if we added some feature like type of or something, then that might change the story here. And then we would have to be careful. The problem would be then you wouldn't be able to use this tick A inside the value of an associated type.
Seems like because I think there have been some suggestions that we would support type of that we should be a bit careful. When you said that we could special case, I don't recall if you said we could do it on a permanent basis or a temporary basis.
What I was saying is I think we could do either. Like if we wanted to do a warning period, it would be possible. It's a little bit annoying because it's region inference, but I imagine we could do it. I mean, what we'd have to do is, walk in this particular case of this kind of type, we would walk regions and add
This
them
is,
to the special line.
but this is in LLL, not in region check in the type checker, right?
It's sort of before that, actually. It's part of the well form in this code. There's some code that defines what it means for one type
Yeah.
outlive a region.
I see.
I would
This is
rather
probably
have two things there. I'd rather keep it simple if we can.
This is probably part of type checking path expressions. There is something about registering some obligations there.
Maybe.
It feels familiar or something.
I think this stuff usually in the compiler, like if you're looking for it, I think it's usually like under things named outlives, like it's explicitly marked as such. The problem is there's like 3 or 4 of them. At least one of them is some choke integration, and I'm not sure which one was this.
3 or 4 of what, Eddie? Sorry, I didn't understand that.
Outlives, like modules. Outlives.
The coding
so,
question is,
not to get in too deep into compiler terms, but we have check expression expert path, and then we have just before we return the type, we have add well formless bounds. We call it that function.
I believe this is.
Well, yeah, like everything that's that you're bringing into a function, let's say from definitions outside of it, has to go through well-formed checks. But it's not just like almost everything is well-formed check.
I think we should move on in this meeting, and
yes,
Eddie and I can write a comment with a little more detail and explain a little bit of the background, and revisit it. We have a lot to do in this meeting.
By the way, at least for prop test, since I'm sort of the maintainer of that crate, I can issue a point release, but I can't speak for any other crates.
Yeah, I would like to know if we start seeing other reports of this too.
Yeah, we did for struct opt.
Right. It looks like struct opt has a fix already.
No, it's blocked on a fix, I think, or something. Perhaps. Maybe we would need to check. So sorry. So skipping the coherence and PNSM sound thingies. Lifetime balance in auto traits impulse prevent traits from being implemented on generators. So this is behind Noah-Sama's problem, mostly an impl issue. Nico should prep or write up or something, and you probably didn't do that. So, sorry?
Long-standing to-do item. I didn't get to it yet.
So let's skip it. All right, nominated PRs. This is one of Eddie's. Move the string slice type to the standard library. This one is a bit interesting. Eddie, do you want to talk about this?
I've actually that's a PR description that's in the paper doc. I just recommend letting Petr Chenkov take over it. Since I only did this because you remembered about it, but he seems interested in actually continuing this work. So,
right. But there are no
better motivation, I think.
But there are no like language problems introduced by doing this, and we could change our minds if we wanted to, or something.
Yeah, as long as we don't start, don't start exposing too much of this, like if we don't start adding things in the standard library that don't make sense when it's built in, if the interfaces are all look the same, it's probably fine.
What's
That's
the motivation? Just to simplify the
And I've tried to, like, the first iteration
Awesome.
doesn't even change name resolution. Like, you still have to write str and you can write it anywhere. It means the same.
yeah. It did sort of feel like a wash in terms of, well, it's sort of a special case in many cases still. Some diagnostics got improved, some regressed. Those that regressed are probably fixable, I think.
Yeah, they talk about byte slices. Like,
I think that's
STR
a,
is, yeah,
probably
if
consider
STR
that
is
an
in the
improvement.
library, if STR is in the library, then STR is unsized because byte slices are unsized.
Yeah,
So
I was
that
mostly
ends
thinking
up
about non-exhaustive patterns diagnostics, but those are probably fixable.
This is accurate. Space
anyway.
clean up,
I don't know if
kind of.
Yeah, I think that's accurate. So what do we think?
Name resolution, Eddie, after this PR, is there any, is that the only place that sort of knows about stir in any particular way?
No, I mean, if you look at the div, there's in almost every single place that mentioned types stood before, it's now like there's an is method that checks for it. Like I've kept most of the checking in. It's just
Wasn't there?
a proof of concept. It's not like the first implementation does not remove a lot of special cases.
Okay.
Only when the ADT implementation is like clearly correct and does the same thing.
Didn't Petruchenkov suggest something like adding it to the prelude or something?
Yeah, like I said, like Petruchenkov has this sort of
Yeah.
I should put the pull request. No, not this.
I think
in the wrong place before.
Be vital right now.
to me it's not obvious that this is an improvement. In some cases, well, the diff sort of is reduced, but it's not obvious, I think. But from my perspective, as long as this doesn't lock us into, like, we couldn't change our minds, I think it would be fine. It's sort of how I feel.
So Petruchenkov said that there was an attempt back in 2014, and they wanted to get this done back then, and they still want it done. So basically, like, if there's any arguments for it, like, I would let Petruchenkov speak for them. Like,
Right.
I would just, like, I did this. I don't have any intent on actually like pushing this through. Like convincing people about it.
You just
like
thought
not
it
a
was
lengthy issue at all, to be honest. I mean, it's sort of user neutral, but it would be nice if we can sort of show conclusively that stir is not special. It's in the library.
It would be plausibly return to the Langting if we wanted to do something special with it again, and we couldn't, for example.
I mean, it's a lang item, so
yeah,
you can.
That's also true. I think we can. I personally feel we can merge this, but let's be a bit careful about not being able to change our minds, perhaps.
Merge it after we've resolved the performance issues?
Oh yeah, sure.
Oh yeah, those are fun. I think they're basically long-standing bugs that this just exposed.
Now that might be the actual prize here.
Since any struct without any generic parameters like has the same slowdown compared to a built-in, and I don't think there are many cases in which that should be true.
Yeah.
Like ideally.
does anyone disagree with the notion that we would merge this? Try to be a bit careful about not not tying our hands, like not being able to change our minds later, and of course dealing with performance regressions and diagnostics regressions and whatnot.
I have no strong opinion about this.
Okay. I guess, well, if no one disagrees, that is the conclusion, or I'm not sure.
I think it's fine. I think we can give line team, line team is fine. The extent that we care about this.
Do you want to
All right.
summarize?
Yeah.
Thank you. So moving on, update discriminants. So this is, I think mostly I wanted to highlight this. There's probably not a lot to discuss here, but what this changes is that instead of always having U64 as the discriminant for an enum or a struct, also works, it uses something that fits better for the type by projecting to an associated type internally, which is not exposed, and the trait isn't exposed either. So it's mostly an implementation detail, but it's but I thought it would be good to know about this. I think it's primarily so that you like 128 bits work. That was sort of the rationale. Perhaps some optimizations. But yeah, that's basically it. And Nico is assigned, so have fun.
Seems fine. Does anyone have a strong opinion about this? It's only user visible in the sense that the size of discriminant changes or something.
Well, it's plausibly user visible through by hashing, but that's an implementation details, and if users rely on that, it's their own fault. They shouldn't be. Which is, I think, definitely the conclusion in the Lips team as well. At least as far as I understand. Right, yeah, size of. We also don't guarantee what size of returns, so same applies there.
Right. Yeah, alignment. There's a few minor details, but those are kind of
Yes.
things you change all the time.
So time check, we're 20 minutes in. And moving on, use explicit promotion for constants in repeat expressions. So this one was a bit hard for me to understand, but I discussed it a bit with Oliver. And so the idea is that we would first check if the type is copy, and after that we would check if it's promotable, or we do some class qualification. I don't know, the terminology is very confusing. Maybe Eddie or Morris know better.
Yeah, so basically it's important that all code we can't start making programs fail to compile because we've tried to promote something and that we weren't promoting before, and then promotion fails. So that's what most of Ralph's concerns are, and that's the main concern with this PR. There was we discussed this earlier, like in a meeting several months ago, and the concern there was we don't want behavior to be super dependent on the type of stuff, like whether we promote. So whether this thing is copy,
Right.
maybe we shouldn't be making promotion decisions on that. But we've sort of tried to carve out a little niche in the design space where we know that we're never going to cause programs to error where they weren't going to be before. And because we're relatively late in the compilation pipeline, it's not too hard to implement. More than that, you'd have to ask Ollie.
Taylor also makes the point that adding copy to type can already change significant behaviors and
Sure.
can break compilation on a linked issue, just to make that point as well. So what this allows now is that you can, instead of having first defining a constant and writing vec new equals vec new in that one, you can just inline the constant into the elements expression in the repeat expression. From my understanding, at least when I discussed this with Oliver, Eddie had the idea that we could potentially allow runtime expressions, and from my discussions with Ollie, this would be forward compatible with doing that in the future if we wanted to. At least that's my understanding.
Runtime initialization, meaning that we would actually execute the initializer n times at runtime for
Right.
an array of length n, as opposed to just once and then copying it into the array n times.
Right. That would also have the side effects, so that might be great.
I have a question. We've discussed on and off the idea of explicit const expressions that opt into
Yes.
promotion. And it seems like we haven't really done anything with that idea. But if we
I
have,
think Oliver has a prototype somewhere. He hasn't finished it, but I believe. Yeah.
This is the anonymous const block thing where you write const braces.
Yeah.
I think it's fairly appealing idea.
Like const new 22 or something, right?
Yeah, you would have braces. I believe it is the, but yeah, bike chat, not too important.
You would have braces around here. There are, I don't really care, but I am curious. It's a point to understand why, but okay. Yeah.
Yeah, this maybe is probably
to some extent, but I feel like I might be happier starting with that, which is sort of not controversial, addresses the use case in a uniform way that will work for all types. And then if we're like, oh, but it's so annoying, this common case, it's still too annoying, maybe we should sugar it. That would feel
I think that's reasonable.
I'm down with that.
Seems reasonable as an intermediate step.
Because I feel like we want this, we know we want this anyway, right? Like there's enough corner cases around promotion and stuff where it'd be nice to be able to say, yes, compiler, you can't figure this out, but I swear it's a constant and I want to borrow it.
I feel as though this is not too complicated to specify. It's probably not too complicated to implement. It seems like a good idea. Even maybe just adding it to nightly before an RFC could be something we do. We probably want an RFC though.
I'd want an RFC, but we could experiment it beforehand.
Yeah, exactly.
To have the syntax discussion a little bit. I didn't what I said.
I still probably feel I don't fully understand everything Ollie was saying, though, even though he tried to explain very slowly to me. But so that might mean some things we've missed here. But it doesn't feel like adding this construct is something that can go wrong. is there anyone who feels that we should merge the PR as is and not do anything about the const block, or that we should do both or something? Is there anyone who disagrees with the?
I'm just. Are you saying anyone disagrees with my compromise proposal?
Yeah, I'm just asking the room. Does anyone disagree?
I think if Ollie were here, they might, but
yeah, unfortunately,
I don't.
Ollie can't really attend on Thursdays. But they said they would probably have an easier time on Mondays.
Yeah.
So they might be there next time.
But yeah, I don't have a problem with the compromise. Seems good.
I'll post a comment about it. Maybe we can try to arrange a time to dig a bit with Ollie that works for them. Probably won't be a design, you know, if one talk about the strategy.
I think they can probably leave a comment or something if they I would be surprised if they would disagree strongly or something.
Yeah, that seems fine. Okay. I'll write a comment, I guess, since it was my suggestion. Unless someone else wants to.
I think as long as we, if we end up with a tracking issue for the anonymous const blocks, we should probably have a checkbox item in that for review how much of a pain this is before we stabilize.
The constants in repeat expressions.
Pardon?
Stabilizing which one of them? The repeat expression thing.
I'm saying if we're going with this compromise of suggesting that people use an explicit const block in this context, then we should have some checkpoint where we actually go back and say, is this enough? Do we need to take a step further? I would like to avoid the case where we just forget about this.
Yeah. I mean, I think that sort of applies to.
I added a note, by the way. Seems good. Moving on, and time check, 28 minutes in.
This issue.
Limit maximum alignment in vector align to 4K. So there was some new feedback since last time we discussed this. Does anyone have an interpretation of the feedback? If you'd like to.
So the author of the MLIND crate wrote, and they're using what seems to me to be sort of an embedded like use case, some kind of camera that they need to copy data from, and they needed specific alignments. And they found that this structure was useful because it lets structs be generic over their alignment by having a bunch of types at different sizes that you can use, which is a nice hack actually. But they didn't seem particularly perturbed by the idea of having a limit like 4K. I think it would not cause a problem for them. They just sort of made it as a bunch of.
Yeah, I think they jacked up the limit. Well, not the limit. The size, the maximum size they used, the maximum alignment they used because they could. They didn't actually need it.
Which makes sense. There wasn't, I think, any real responses from. I don't remember if there were responses from embedded group. Actually, I think maybe there was. I forgot about them.
My view is that there wasn't significant opposition or much concern about enforcing this on the type.
Yeah, I think that's probably right. There wasn't significant opposition expressed.
Sorry, can you repeat that?
I think you're right that there was not significant opposition expressed in comments. I don't think it has changed the fundamental. I mean, the main thing is things exist. We don't know about that. But, yeah.
And I think at least from a language consistency point of view, post-monomorphization errors is not something we aspire to have.
I mean, kind of by definition, anything that is not going to be known until you get to a linking step is going to be after the monomorphization step. So some of these things will get caught by the linker.
Yeah.
I suppose, but
I don't think there's anything necessarily wrong with that.
I think there are. I mean, there are some limits to where Rusty ends, so to speak.
Right.
But I think Cogen is not that.
So I think I'm wondering something slightly different here. Is our goal here to warn that you put this in and it might not have an effect? Or is our goal to catch an actual bug in which we can't detect that it didn't have an effect? Are we trying to take an error that is going to happen at link time or similar and move it earlier? Or are we inserting an error that wouldn't actually be an error at link time?
I think we are preventing a runtime problem.
It's the latter. I think what's happening is there would be silently, the attribute would be ignored, and that can cause problems because there may be code that assumes the alignment is true and it's not.
That would certainly be an issue, yeah.
I'm not sure.
Unsound, the soundness.
Right, hence the soundness hole.
So,
I'm not sure exactly like what code. That is to say, I don't know if there's like LLVM code that we're talking about, or if it's like hypothetically users might make this assumption.
Well, I think to go back a step, well, normally I would think it would be users putting this in. A common case for alignments this big would be things like, oh, it has to be aligned to this so that I can put this address here. Just
Right.
as a...
That would be my assumption too.
Pardon?
I agree with that.
I mean, I do know of platform-specific cases where you need, for example, something to be on a 1 meg aligned address. Normally, you do that with dynamic runtime allocation rather than static allocation at link time. But I do know of platform requirements for things like 1 meg aligned items.
It looks like in
I definitely.
Sorry, I was just going to say it looks like at least one case the linker does error as well. Kind of both, maybe. But go on.
It definitely feels like this isn't a hint because the only reason you're doing this is because unsafe code needs it for some reason.
Right, exactly. This when you're doing repr align that big, it's not going to be, oh, I think we need to do this for performance. It's going to be, if this doesn't work, the program is wrong. So that much I can understand. If we can't enforce it, we should say so. But on the other hand, what is somebody's recourse if they are actually able to enforce it on their platform and Rusty is just not as smart as their platform is?
For the embedded use cases, the alignment limit is enforced per target, and for the embedded use cases, the limit was higher. And you can change it if you can also change the target limit by tweaking the target. And
so
you can also use the allocation API. Sorry?
So the proposal is to have a target-specific limit here, not to globally limit it to 4K on every target.
Yes, correct.
Okay.
Yeah, the 4K thing was just a canary to test some common thing.
And so,
Really how much we're worried about the backwards compatibility side of this. I continue to feel like, well, I agree that it's not. I don't know what I think. I do think this is the kind of thing we could give an error after monomorphization for, and it would be consistent to my mind.
Yeah.
Like you exceeded weird limits. But
well, the other thing that I think justifies making this post-monomorphization, as in very post-monomorphization, is that when you are exceeding a target-specific limit and you expect this to be something like, oh, your symbol has weird properties and I noticed this at link time, then it doesn't seem especially unreasonable to catch that in the back-end link as opposed to all the way in the front end. This is a very unusual case. So it's really a question of, is it easier for us to catch it in the back end than the front end?
I don't think so. From Manu's description, it was more complicated to do this on statics than doing it on the type itself.
Yeah, I think it's easier to do it in the front end. Because we're just doing it sort of in one uniform place. I don't know if it's so much easier, but it's definitely feels easier.
But it would presumably be in the type checker or something.
Right. We're basically doing it when you define the alignment. Because it's just not legal to have a big alignment, full stop. Versus
we used to have a very limited wrapper line attribute, and it was checked pretty early. I think it might have been to the 16th, so like that would be 64K. So it was that for a while, I think. I'm not exactly sure when we changed that, and I think then at some point we just let it be whatever, as long as it was a power of 2.
mm-hmm.
Can we put this right next to in the layout check that's already doing the target specific check for the size of the type? Would that make sense?
You're referring to the size overflow checks, right? When an array would be too large to represent its size.
That is post-monomorphization, I think.
Yeah.
We could do that for alignment, yeah.
The
That's
problem
one.
It
is
sort of feels like the same layout check to me in a way. I'm not usually a fan of monomorphization time, but since that layout check is already monomorphization
like
time and target dependent.
I think that's the worst of both worlds because you're enforcing it across all types and not only for types that appear in statics, which means you are still going to affect all the crates, but you're also doing it late when we could have done it early. If I'm not mistaken.
Yeah, the static versus non-static is a good point there.
And also the way I rationalize the post-monomorphization aspect of the size overflow check is that it's almost like a resource issue. Like the same way you couldn't, compute some value in memory if you couldn't fit it there. Like you could imagine generating a constant array with MIDI that just doesn't fit memory. You can't give it to LVM because you can't compute it. So in a similar way, we have types that can't be represented. Whereas alignment, we can definitely represent the alignment. So I don't know, that's just my view on it. If we can do it early and not break much, I don't know.
We have to fix that one crate, or we don't know exactly what we break. We know we break at least a few crates. There is some alternative.
My view that the breakage numbers were not significantly, at least.
They have to switch. Yeah, we break. There's 3 crates. Three boot.
Especially if the breaking cases are things where the linker is not even enforcing, the OS isn't enforcing the request in the first place, right? We don't know.
Cases. They're not those cases.
They're not those cases?
They're the cases where everything works. At least, MLine D could probably be used for many things. It's kind of a generic library, but the like other use cases, allocating a stack frame or something, although there are some LVM bugs, so maybe that too.
This is enforced on the type, by the way. So so this is catching so this is catching as many errors as possible.
I'm just saying those are these weren't cases where people were making over-aligned statics. That's all I'm saying. That's the whole reason they wouldn't be affected if we switched to the narrower check. Hi.
Oh, How so?
Because that's not what they were doing. The types weren't used as the types of statics. They were used as types of other things.
Oh,
I think they were heap allocated. In one case, it was a heap allocated, like it was the stack for a new thread. They wanted it aligned to a page boundary, which you could do with the newer, now stabilized malloc APIs or whatever.
but this should at least catch any alignment that is too big on type definitions.
Yeah. I think we're not, I feel like we're talking a bit past each other. All I was saying is Felix suggested that maybe we're only giving errors to crates that weren't going to get the alignment they expected anyway, so it's sort of not, it's like we're giving them an error they should have gotten, but I'm saying that's not the case. As far as
Well, I was at least trying to say that some of the crater breakage could be cases that fall into that category. I don't know, but so I wasn't trying to claim that all of them were blanket, failing at runtime. I just meant that it might be a misnomer to say that all of these cases of breakage represent things that weren't already broken at the OS level.
Yeah.
Sure. I don't think that's, at least I wasn't making that argument. I was just saying that the number of regressions are few. It's not that many.
I think we can probably go ahead and enforce it at the type level, or at least try. I'd like to do it maybe at the start of a cycle or something to give people time to raise concerns. But
Yeah, sure, that seems reasonable.
I'm not sure if we discussed whether it's per target or not.
We did.
Because okay, because it feels like maybe the crates that are used creating so defining structs with very large alignments are unlikely to be used on the targets which have the problems. Like maybe there's a way this can all work out despite being very strict.
we could also do a warning cycle. I think that may be a good idea.
Or just a permanent warning. Like this may be unportable. Speaking of the portability link.
Well, it's more like it's actually the mainstream platforms that have the lowest limits because they're the ones that use dynamic linkers that don't enforce the constraints.
Oh, okay. So yeah, I must have confused it with something else. Okay.
I think a warning cycle would be a decent compromise.
That does raise one interesting question. The limits are apparently different depending on if you are linking statically or dynamically. And one target can potentially support both static and dynamic linking depending on which options you pass. So I'm wondering if it makes sense to have a target-specific link, a target-specific limit, or if the limit needs to be the larger of whichever is supported by static and dynamic, and then we enforce something else later when we detect which one you're doing. And we may not even know which one you're doing because you might be compiling object files and then linking them separately.
I was assuming we would do the more conservative of the two, but yeah, that is something that's been in the back of my mind that we don't necessarily know if you're going to be doing dynamic linking or not.
Right. I don't want this. I don't think doing the more conservative of the two necessarily makes sense because then you are preventing people who are using that target with the more capable linking model from doing something that they were previously capable of doing.
But you are, but they have work. You are, but if you don't do that, you're not actually fixing the bug. And if you and they have workarounds, like they can, in most cases, I mean, the assumption here is that few people actually want to do this, and that the majority of the folks who do either have another decent option or are on some embedded platform where it doesn't matter.
I see. So the claim is effectively that people who are using this should be migrating to something that does a different kind of allocation.
Right, so for heap cases, they could use like an extended malloc kind of thing.
Right. And for non-heap cases, in theory, they could use a linker script.
Or a custom target, I guess. I'm not sure. I'd like
Right.
to see a write-up that has all the, what are the workarounds.
Time check, by the way, 15 minutes left on the meeting, so.
I do rather wish that we had better ways of integrating linker scripts into a Rust build process, but that's a separate problem.
So for now, it seems like there is no one who is objecting to enforcing this at the type level and doing a warning period.
So a warning period, that seems fine. What I just said was very much intended as an objection to an error if we find out that there isn't a reasonable alternative for doing things like statically linking in such a way that you can use these limits.
Sure, people can raise.
I don't have an objection to going through a warning period and making sure that people who are on embedded or unusual targets have an opportunity to provide input.
Yeah, we can CC them.
Why don't we think that we should, comment that we were thinking of this, and we would like a sort of write-up that says, here are the known use cases, and here's what you should do instead. Right?
It's good. Well, Nico, you have a lot of comments to write. Can you handle more?
Why not?
Okay.
All right.
Let's see. Perform well-formless check on type aliases with no type parameters. I think we want to discuss this in a design meeting. You've sort of discussed the time for that one.
We have a time.
Which is,
yeah. 20th.
So we should
Just
probably
added a
do.
note suggesting the warning text should point to an issue where we're getting feedback.
That's always
Yeah.
Okay.
Standard procedure.
Yep.
Yep, definitely.
Hard-coded in the compiler. So I think we can skip the type alias thing now. So there's this proc macro stabilize span result at and span located at. These are mostly for improving diagnostics or basically improving diagnostics in procedural macros and check your boxes and stuff. For example, Scott and Nico. Moving on, there is a discussion about whether enum discriminants should have type parameters and so on in scope for the discriminants. Sorry, whether enum discriminants should have type parameters, etc. in scope. And the sense of the issue, I think, is.
Second, can I interrupt for a second?
Definitely.
There's some duplication. I've written a whole thing somewhere down the document. Like this is way too long, and I wrote a wait. Oh right, I see. Yeah. Yeah. This item is twice. It's once at the top of nominated issues, and it's second time lower down, and I've written a whole thing down there.
Oh, I see.
I've reformatted the information in the issue, so it's easier to.
Yeah, I see.
Should be kept. They're supposed to be in sorted order, so this is probably the right spot, I guess.
Sorted by number.
Sorry about that.
Well, there is the current leading proposal, I would say, is that the answer to the question is yes, which is a bit surprising, I suppose. But I would recommend that people read the issue and leave opinions and stuff for now.
This is something I would expect to work given the ability to do const generics.
Oh, I should have tried the constraints. Yeah, it might be possible to. Well, actually, no. We can't really choose congenerics. Like see the square bullet points. You you'd have to be able to know that the discriminants don't overlap. So the only thing that we could allow right now is when there's only one discriminant, like only one variant really. And we could like add some special cases, but unless there's some
Yes,
way to
please
say
not.
that two congenerics or like a congeneric isn't zero, so like you could only pass other values. Like before we have anything like that, we can't really allow actual generic values.
I mean,
Um,
we could as a
this is more of a
normalization error, right?
Not do that.
no.
Why?
No, we like this is the requirement for discriminants to not overlap is a very early type check error.
But is there any reason it has to be?
I mean, well,
In any case, it's not what we're deciding now, right? We're deciding
Yes.
now
for
how
pattern, there's one thing where pattern matching refers to discriminants, and we'll probably have to change the tag. Now, like we'll probably have to do a lot more changes if we want to actually push the check later, and it's probably not worth it. This is
But
just about being able to name them, not actually generic.
So my suggestion is if you would like to elaborate on that, it would be good to do it on the issue, perhaps. But I think process-wise, since this is still unstable and very far from stable, we can just let the reviewer take care of this, and if people have concerns, they can leave comments on the issue or the PR. And
wait,
yeah,
what is far from stabilization?
constraints.
But this has nothing to do with congenerics.
All right.
Like for my examples, use type parameters.
Yeah, that's true. Yeah, that's true.
The only way there's an explanation. Okay, so there's an explanation. If you see congenerics in examples, that's only, and I try to stress this, that's only to work around the bug. And my pull request, which replaces the ICs with proper errors and whatnot. So my pull request for choosing option 2.
Yeah, you're right.
Works at like has a completely different workaround, and you don't need congenerics in like in the test of that pull request.
So I take that back. Do we want to do an FCP or do we opinions?
I'd be fine with an FCP. This is not high priority.
Seems like an obvious.
So it could even wait.
Sorry, Nico, you were saying.
I think an FCP is fine.
Yeah. And the reason I interrupt. The reason I brought up the stabilization thing is, there is a blocker to using this on stable, which is arbitrary non-discriminants. Because if you have a generic, if you have like type parameters, you can't not use them in invariant fields. Like they have to show up as data right now due to variance. So that is actually blocking, a fully compiling example, like
I believe, however, that is something that someone is eyeing towards writing a stabilization report for.
That's what I'm like trying to point out with the last example. That might be more relevant than constraints.
That's fine.
All right, let's do an FCP.
I'm gonna have to get off. I have another meeting for sure.
5 minutes.
Or something short.
Just a few quick notes. Resolving OK wrapping for try blocks. Josh has proposed that we would agree to use OK wrapping for try blocks, and I separated out an issue for that consensus building, and well, read the text, read the proposal, check it out, and check your boxes if you agree or do something else. I think the F1 used is something we won't get to. For the implicit caller location, that is track caller, ANP has written a good PR documenting the feature in the Rust dev guide, and has written a report for stabilizing the feature. There are, I think we should probably wait with stabilizing this a bit. It should probably still be feasible to do it in 1.45. Well, it's too late anyways. Right now, it wouldn't land in 1.44 in either case. EDB, however, has discovered some remaining issue that needs to be fixed first, I think. I'm not sure if you wrote anything about that, Eddie.
I mean, it's still like, okay, so I haven't opened the proper issue, but if I, having both Zoom and paper is really making this hard.
Yeah, just talk about it instead of writing it.
Yeah, no, I wanted to link it because it doesn't show up on GitHub. It's hidden by default, so that's okay. There, I pasted the comment link.
Okay.
Right. So if you go to Playground for that, and actually run it, you can see that the panic message is not what, it's nothing like what you'd expect. It's actually worse than it was before caller location. It's inside the macro panic. And that's because we don't track the actual macro backtrace. We don't track anything like hygiene or macro related information across screens. So it just happens that the span we keep is a really useless one.
Right.
And wait.
And this is actually observable on, yeah, and it's observable on stable as well. That's not great.
Yeah. So it's something that or what's happening?
I'll break an issue out for
I
it.
guess I'm catching up now, or I don't know if, or maybe Nico.
Thanks, Nico.
Wait, that's a GitHub feature?
Yep. Pretty useful.
I've never seen that.
What am I doing?
They're adding a bunch of new good features, I think.
Well, I guess I'm not going to open that issue myself if Nico.
No, Nico is.
Well done.
All
All right.
enough. Yeah, so
kind of I mean, it's, I don't know.
try.
Like it affects it anyway, and it's kind of an implementation bug, right? Not like stabilization seems semi-orthogonal from this bug.
True, but it also feels like we're releasing something of subpar quality, and we're like saying, okay, yeah, but we're like promoting it even more and saying that okay, users start using this feature in your this attribute in your own stuff, and it might have like serious usability bugs. It feels like that's maybe not the best experience.
Okay, I'm not. If the method did not have track caller, we wouldn't have this problem.
No, it's so what's happening is it's just the code gen is it happens another crate. So you have a generic function like this doesn't require the user to use track color, so that could be an argument for not blocking.
Let's discuss that issue, but X, I gotta go.
Yeah.
But I think I'm okay to block until we fix it. Either way, I don't have a strong opinion.
Yeah.
Yeah, I only wanted you to like the only thing I wanted you to do is open the actual playground example, so we can all see how bad it is. But that's yeah.
It's pretty bad in here.
All right. I'll see you all later. Ciao.
See y'all. Thanks, everyone.